Imagine a world where days last only 3.5 Earth days, where temperatures are so high they could melt lead, and where the atmosphere is so inflated it seems to defy the laws of physics. Welcome to Kepler 8b, one of the most fascinating exoplanets ever discovered. Want to know more? Stay with us. Hello, astronomy enthusiasts. Today, we are going to explore and learn about one of the most intriguing exoplanets discovered by NASA's Kepler mission, Kepler 8b. This gas giant, located about 3,000 light-years from Earth in the constellation Lyra, offers us a unique view of the so-called hot Jupiters. Get ready for a fascinating journey through the cosmos. If you like this topic, consider leaving a like and subscribing to our channel, because this way you show YouTube that our content is good and helps our growth. Kepler 8b was discovered in 2010 as part of the Kepler mission, launched in March 2009. The mission aimed to find Earth-like planets in habitable zones around other stars. Kepler 8b stood out as one of the first successes of this mission, revealing a world completely different from ours. The Kepler mission used an innovative method of detecting exoplanets by observing the dimming of stars' brightness when a planet passed in front of them. This method, known as the transit method, allowed the discovery of thousands of exoplanets, including Kepler 8b. Classified as a hot Jupiter, Kepler 8b is a gas giant that orbits extremely close to its host star. Unlike the gas giants in our solar system, such as Jupiter and Saturn, hot Jupiters have inflated atmospheres and very high temperatures. These planets are called hot Jupiters because, like Jupiter, they are primarily composed of hydrogen and helium but orbit much closer to their stars, resulting in elevated temperatures and expanded atmospheres. The proximity to the star also means these planets have very short orbital periods, completing an orbit in just a few days. Located approximately 3,000 light-years from Earth, Kepler 8b resides in the constellation Lyra, visible in the northern hemisphere and famous for the bright star Vega. This distance is measured using advanced astrometric techniques such as stellar parallax. Stellar parallax involves observing a star from different points in Earth's orbit around the Sun, allowing the distance to be calculated based on the apparent shift of the star. The constellation Lyra is one of the oldest and most recognizable constellations and hosts many other interesting celestial objects. Kepler 8b completes an orbit around its star in just 3.5 Earth days. This extremely short orbit results in constant exposure to intense stellar radiation, creating a hostile and fascinating environment. The planet's proximity to its star means it is subject to extreme tidal forces, which can cause additional heating and influence the planet's internal structure. Additionally, Kepler 8b's rapid orbit means it experiences significant variations in the amount of radiation received over a single day, which can have dramatic effects on its atmosphere. With a radius 1.42 times that of Jupiter, Kepler 8b is significantly larger in volume. This inflated size is likely due to the intense heating from the host star, causing the planet's atmosphere to expand. Atmospheric expansion is a common phenomenon among hot Jupiters, where the energy received from the star is sufficient to heat and expand the planet's atmosphere. This results in planets with larger radii than expected for their mass and can influence the atmospheric dynamics and chemical composition of the planet. Despite its large size, Kepler 8b has a mass of approximately 0.6 times that of Jupiter. This indicates that it is less dense, a characteristic attributed to atmospheric expansion caused by the star's extreme heat. Kepler 8b's lower density suggests it has a very thick and inflated atmosphere, with a composition dominated by light gases such as hydrogen and helium. The low density may also indicate the presence of complex internal processes, such as heat circulation and the formation of high-altitude clouds. Temperatures on Kepler 8b are estimated to be around 1,600 K, or approximately 1,927 degrees. This high temperature is a result of the planet's proximity to its star, which provides an enormous amount of thermal energy. The star's intense radiation heats the planet's atmosphere, causing the formation of strong winds and violent storms. The high temperature can also lead to the formation of silicate clouds and other exotic compounds, which can influence the planet's appearance and atmospheric dynamics. Kepler 8b orbits an F-type star, which is slightly larger and hotter than our Sun. F-type stars have surface temperatures between 6,000 and 7,600 K and are known for their white-yellow color. Kepler 8b's star is more luminous and emits more ultraviolet radiation than the Sun. The star's higher luminosity and temperature mean that Kepler 8b is subject to higher levels of radiation, which can influence the composition and structure of its atmosphere. F-type stars are relatively common in the galaxy, and many of them host complex and varied planetary systems. The planet was detected using the transit method, which observes the periodic dimming of the star's brightness when the planet passes in front of it. This method allows the determination of the planet's size and orbit and is effective for finding planets that orbit close to their stars. The transit method also allows for the analysis of the planet's atmosphere by observing the starlight that passes through the atmosphere during the transit. This can reveal information about the chemical composition and structure of the atmosphere, providing valuable insights into the nature of the planet. Kepler 8b's atmosphere is believed to be primarily composed of hydrogen and helium, similar to the gas giants in our solar system. However, due to the high temperature, the atmosphere may contain silicate clouds and other exotic compounds. Kepler 8b's atmospheric composition may be influenced by the star's intense radiation, which can cause the dissociation of molecules and the formation of new compounds. The presence of silicate clouds can influence the planet's appearance, causing variations in the observed color and brightness. Kepler 8b is an example of an inflated planet, where the proximity to the star causes intense heating that makes the planet's atmosphere expand. This phenomenon results in planets with larger radii than expected for their mass. Atmospheric expansion can influence the planet's internal dynamics, causing the formation of strong winds and violent storms. The inflated atmosphere can also affect the planet's interaction with stellar radiation, causing variations in temperature and chemical composition over time. Due to its short orbit, Kepler 8b has a very high orbital speed, moving at approximately 150 km/s around its star. This high speed is necessary to keep the planet in a stable orbit so close to the star. Kepler 8b's high orbital speed means it experiences extreme tidal forces, which can influence the planet's internal structure and atmospheric dynamics. The rapid orbit also means Kepler 8b experiences significant variations in the amount of radiation received over a single day, which can have dramatic effects on its atmosphere. The discovery of Kepler 8b helped expand knowledge about the diversity of exoplanets and the dynamics of hot Jupiters. Studying planets like Kepler 8b provides insights into the formation and evolution of planetary systems, especially under extreme conditions. Additionally, observing inflated atmospheres and their interactions with stellar radiation contributes to understanding the physical processes occurring in exoplanets. Research on Kepler 8b and other hot Jupiters continues to reveal new information about the diversity and complexity of planetary systems in the galaxy. Kepler 8b offers us a fascinating view of a distant and extreme world. Its discovery and study continue to enrich our understanding of the universe and the various types of planets that exist beyond our solar system. If you enjoyed this video, don't forget to subscribe to the channel to support our growth, leave a comment about a topic you'd like to see, and share it with your friends who are also passionate about astronomy. Until the next cosmic exploration,